Alright, working the gas law trilogy here. We got Who's Got Gas Part 3. We've talked about the original three people that had gas, Boyle, Charles, and Gay-Lussac. And then we talked about combining their laws together to make one big, fancy, easy-to-remember formula in the combined gas law, P1V1 over T1 equals P2V2 over T2. And so today, we need to learn a little bit more about gas. And so the combined gas laws and Boyle and Gay-Lussac, they're really good for if we're changing the conditions of some gas. So if I have a pressure and a volume and I want to change the temperature. So I'm putting them into new conditions. But a lot of times, I don't want to put it into a new condition. I just want to know what's going on with the gas that I have right now. Okay? And so that's kind of where the ideal gas law comes in. It's going to take all the possible parameters of a gas and put them together into one formula. So it's going to look at pressure, look at volume, it's going to look at temperature, and it's going to look at number of moles, or how much of the gas I actually have in that container. Okay? And so we have the ideal gas formula. Okay? PV equals nRT. Okay, so two formulas you really need to know here. P1V1 over T1 equals P2V2 over T2. Okay. And PV equals nRT. Okay, and so what do these all mean? Since we're not changing criteria again, we don't have numbers on there. So it's just a pressure, and it's not an initial and a final. But we have P is pressure, V is volume, N is the number of moles that you're dealing with, T is in temperature, and temperature is always in kelvins. And then you have R, which is something we're going to talk about right now. It's the ideal gas constant. And so, bam, here's your ideal gas constant. Okay. The ideal gas constant is just a numerical way to kind of link all of the different units that we're dealing with together. Okay. So it's a given value. It's a constant that will help make all the math work out for you. And so really, the biggest thing that you need to know is this one right here. Okay. That R is going to be 0.0821 liter atmospheres per mole Kelvin. Okay. That's the most common one because we almost always deal with atmospheres when we're talking pressure. Now you can deal with kilopascals. It will deal sometimes with millimeters of mercury. If that's the case, there's a chart in your book. It's on page 435. It will give you those R values because the number will be a little bit different. Because remember, for atmospheres, the standard pressure is 1, but millimeters of mercury would be 760. So this number will be significantly higher for an R value that has millimeters of mercury in here instead of atmospheres. Okay? So, example problem. If the pressure exerted by a gas at 25 degrees Celsius and a volume of 0.044 liters is 3.8 atmospheres, how many moles of gas are present? And so, again, I make my little sheet over here. I'll chart over here information where I have my volume of 0.44 liters, my temperature at 25 degrees Celsius, plus 273 to get myself to kelvins, 298, my pressure, 3.81 atmospheres, my number of moles, which is an unknown, and my R value, which, since my pressure is in atmospheres, I can use 0.0821, okay, liter atmospheres per mole Kelvin. And so now we just stick them into the formula, PV equals nRT. Okay. So 3.81 atmospheres times 0.044 liters is equal to X times 0.0821 liter atmospheres per mole Kelvin times 298 Kelvin. And so I would rearrange, and what happens is atmospheres are going to cancel out, liters are going to cancel out, kelvins are going to cancel out, and what I'm left with is moles. And so now I would just do the math, 3.8 times 0.044 divided by the quantity 0.821 times 298. And if I do that, I find out that my 0.04 liters of gas at 3.8 atmospheres and 298 kelvins in temperature contains 0.00685 moles of whatever gas was inside there. And so that is the ideal gas law. There's a quiz on there. It'll be due Friday before school. You'll have your worksheets to work on in class. Make sure you turn everything in before you leave on Friday, because I'll be after you. Fling some dirty diapers your way or something. So get your homework done, get your quizzes done, and be good to go for Monday. Monday we got ice cream lab, and we'll probably do some gas law stuff in there, so we'll see who's got gas in class. And we'll talk about some stoichiometry. We'll bring back that fun stuff from 2 chapters ago. Alright, have a great night, and we will see you on Monday.